Alright, let me try and explain where I am right now. I've been futzing with it for about the last 5 hours today. And where I am is it's set up now that it's driving the proper capacity over here, which is the same capacity as before. It's just the 10 in series here, plus 11, 12, and 12 and 3/4. So it's got a little extra here. A couple more of these are turned on. What I ended up doing is I have the output coming through 2,000 watt transformers. Each of the high voltage sides are 220 volts, and that's wired in series for the 500 volts coming out of this. So it comes off of wires 1 and 2, which is in parallel with the exciting capacity bank, and goes out so that these two transformers, 220 volts windings in those transformers, are in series, normal series. And then what I did is I've taken the 120 volt sides, or the 115 volt output sides, and I've put those in parallel because the phasing is correct because of the way they're in series. Otherwise I would have to invert the 120 volt side if I adjusted the phasing on the other ones, on the primaries. But right now it's all just standard series, not common in series. So what we have is normal series, and it has the two 120 volts out in parallel. Because what I found is if I load only 120 off of one transformer or only 120 off of the other transformer, the load causes the voltage to sag a lot, and that voltage isn't actually being consumed, but it's being pushed to the other generator or the other transformer that's not loaded. And that's why I had to wire them up in parallel and get the phasing correctly, so that the output here comes out in parallel, and it now feeds the 250 watt lamp, 120 volt, 60 hertz rated. All of this is coming out at 120 hertz, by the way. It's not 60 hertz. It's going twice as fast as the input because this is a 3500 and that's an 1800 motor, RPM wise. So this is 250 watts, and these are 18 watts a piece. 150 milliamp at 120 volt draw. It's 18 watts. So it's approximately 282 watts, and the voltage is being able to be checked here. Put that bad boy right there like that. All right, so catch the voltage off of this. We'll leave this unloaded so you can see the behavior of the motor as it comes up to speed. And let's go ahead and do it. So, all right, start capacity switched in. Watch the voltages on the wire 2-3 over here for when we want to switch out the start capacity, because when it sags as much as it's going to sag, that's when you want to switch it out. Circulating current right now is about 5.5 amps. You can see it on this one, it's off meter on that one. And then here's the circulating bar voltage that's coming out of the two 120 volt windings wired in parallel. Alright, 155 volts. So watch the voltage, watch the ammeters. Ready? Turn this on. Drop, comes back up, not back up to the 5.5 amps, comes up to about 4 amps, and it kind of wobbles there a little bit. You can see the voltage here is normalizing. in half. It was using 15 UF instead of 40 UF. So using the 3-phase motor, generating the bars with the excited capacity over there, allows for a better efficiency to be passed through. So the question would be, can I get like I don't know, 1,000 watts out? And then how much does the input amperage go up to when I'm taking 1,000 watts out? Because this is constant direct loaded. There's no switching going on here. Everything's set in oscillation and it's just being passed forward. So you can see how much we do. But if it's a 250 watt output per half amp input increase, you know, at some point you're going to cross the threshold. So the question is, where is that threshold?